So yeah, as Boris mentioned, IPFS plus browsers. What's that mean? What's that look like? That's effectively what we're going to talk about today, and how we can turn the Web3 experience of a decentralized web into something that's more useful for Web2 people who don't understand this paradigm or understand its purpose. So a little bit about me. I currently work as a cryptographic security engineer at Brave. I focus mainly on Web3, so I'll do auditing of basically anything related to the Web3 wallet, related to IPFS, and in certain circumstances when we're implementing cryptographic protocols, I'll also do auditing of that. So for example, our P3A protocol, where we have a cryptographic guarantee about key anonymity, that's a project called STAR. Basically, I've done an audit of that as well. So for me, I enjoy working on standards particularly. I've done this at W3C. More recently, I've worked on EIPs as well, and also follow some IETF and IRTF work. So done quite a bit of standards work, and previously worked on decentralized identity, and was a former editor of the verifiable credential spec. So I enjoy playing in both sides of the world of both technical and deep nitty-gritty engineering, but then also the political side of it. So if you need some information, there's that. Also, I do have a QR code for the slides. I have this on every slide because this is actually going to be an interactive demo if you guys want to participate. Also, as a note, if anybody has questions, feel free to raise your hand and interrupt me. This is not meant to be like a lecture for 30 minutes. It's actually much easier if you guys raise questions and ask. So a summary of the talk. Essentially what we'll do is we'll do a brief overview of the technologies first and kind of how everything fits in together. And then part two, I'll do a demo of the technologies being used together. And then part three, we'll actually work on deploying your own IPFS site. So let's jump ahead. I guess the first question talking about the concept is why. So essentially, content is way more enjoyable when it's easily accessible in a GUI. I think everybody is quite aware of this. And the web browser is probably one of the most ubiquitous GUIs available today to be able to access content. This is how the majority of the web is used. If you want to be able to use something like YouTube, people do that. They spend hours of their day doing that. Social media is the same way. Nobody's using their terminal to access Facebook. So with that, this is where we essentially need the idea of a content network. How do we pair it up with a ubiquitous GUI? Enter browsers. So with that, that's essentially the idea behind trying to integrate these things together and make it feel like it works just like the web does today. So a little bit about Brave. What makes Brave a Web3 browser? We've got multiple features that extend beyond the normal web browser itself. So if you think about the web today, most people think about what JavaScript APIs does Google Chrome and Mozilla ship. They think about what's HTML, how does that work? But when you think about Web3, you start to think about these additional patterns and additional technologies and capabilities that are built on that aren't enabled in Web2 and enable new capabilities. So one of those is we have a built-in multi-chain wallet implemented directly in the browser. We actually support Filecoin in there. We also have built-in ENS, UD, SNS, and IPNS domain resolution. So in certain capabilities or certain cases with these, you can actually resolve an ENS name to a content identifier and then be able to register it, and we'll cover that. We also have Brave Rewards that pays user and BAT for opting into privacy-preserving ads. So this is kind of like the model. I'm sure many people are familiar with this. This is one of the key features of Web3 that got us into the space. Also, we have support for a full IPFS node built in. But by default, we actually mapped IPFS URLs to an HTTP IPFS gateway. The main reason for this is it's slightly different in terms of its privacy characteristics. And so being Brave, like one of the things that is our brand promise is trying to promise better privacy. Additionally, this also requires less storage constraints on the user device. So there's some trade-offs that will naturally come, but to me, that's what makes this such an interesting synergy between the two technologies, is if we say the web only works with HTTP, it doesn't necessarily make as much sense, whereas when we say the web works with content addressable networks, then it kind of changes the paradigm and forces people to consider, do I deploy to a server or do I deploy to a content addressable network, and what are the trade-offs I'm making? So what is IPFS? I might skip over this slide. I'm guessing the majority of people here know. Yeah, essentially at a high level, it's a content addressable network. You can consume content comparable to how DNS plus HTTP work is kind of the way that I was thinking about it when I was describing it. Content is hashed, and the hash is used to look up the content and find someone who has it. Rather than serving the content via HTTP IPFS nodes, it relies on libp2p to pass the data as well. So this is like essentially how the network itself works. And yeah, if you want to understand more, there's docs, but I'm pretty sure everybody here knows how to find those and probably has already viewed them. So how is IPFS used today? There's kind of the obvious answer of we share files between multiple parties. That's a very abstract term. Let's get a little bit more specific. It's used to host DApp front ends like Augur. So Augur is a prediction market. I actually don't know if it's still in use today, but the front end is still available. The contracts are still available as well, deployed on the networks. But if you show up at the app, the DApp, it doesn't actually work in the same way as if you showed up at another like random website. So there's other front ends as well. I actually just ported my blog post over to it, so you can do Web 2 content, you can do Web 3 content. There's the obvious answer of Tornado Cache. That's probably a little bit more politically sensitive. There's also, I saw the ability to be able to archive the web. And in certain cases, there are countries who mirror or who block Wikipedia, and so this offers the capability to be able to mirror that content and offer access to that information. So this creates new technology which then plays into different aspects of people's lives. And so that's what makes it very interesting. So part 2 is demo time. I'm going to go to uniswap.eth, and I just realized, back out of there. Okay, everybody seeing it? So this is a very interesting resolution, effectively. As you can see here, we're jumping over to an IPFS CID, and we have access to Uniswap. So why does this matter? So what ended up happening with Uniswap, I don't know if you guys have been following along. Uniswap has basically been regulated in a way that their lawyers have told them they can't launch certain tokens. There's a person in the community by the name Micah who's worked on Ethereum stuff for quite a while as an EIP editor, who basically took the front end, pulled out all their code where they restricted access to certain tokens, hooked it back up to the contracts, and connected it to a ENS domain, where it is able to actually resolve to a CID. So essentially, I'm now accessing a website with a URL domain that's being hosted on Ethereum that's redirecting into Uniswap, and I'm now able to do something like make a swap. So connect to Brave Wallet. And we can do something like this. Connect. And at this point in time, I can basically swap my ETH for something like, say, DAI. So let's say I did. It's grabbing the prices, and I can go through and I can execute a transaction. This is a fully decentralized paradigm. There's no capability to really censor this in any sort of way. If the technologies underneath the hood do get censored, such as at RPC layers, what ends up happening is you can just point yourself at your own Ethereum node. So essentially what we're doing is we're creating a Web 2 paradigm of being able to access your traditional like dApps in a way that becomes uncensorable. And that's where this makes this in a very interesting way, but it's not only about the can we prevent the censorship technology, it's also about how do we deploy different capabilities and make different patterns, such as, can I make this content available in better ways? Can I deploy it out to wider accessible areas when I'm offline, such as like being able to keep this content separate, signing the transaction, and then broadcasting it when I come back online. That's very similar to the concept of how secure scuttlebutt works. So there's a lot of different patterns that we actually are able to deploy from utilizing this that gives us new properties that are not available on the web. So that's a quick little demo. So what just happened? Essentially what happened is Brave browser detected a .eth decentralized TLD. When I typed in .eth, it recognized it and said, hey, I'm not going to resolve this over DNS. I'm going to instead use this other part of the code inside Brave core. And essentially what happened is it resolved the TLD via the built-in RPC service. So if my built-in configured RPC service is actually to Infura, then it's going to utilize Infura in order to make that call. In certain cases, if I am running a local Ethereum node or I'm pointing it in a different direction through Brave's configuration, then it'll resolve it through that RPC as well. Essentially what's happening is it's the RPC, it's contacting the RPC service, and then the RPC provider is pulling the information off the chain. And this is done through a read operation. So if you're unfamiliar with how ENS works, it's basically a NFT smart contract in a way. It was prior to NFT standardization, but it works in a very similar fashion where it does a lookup and reads that off the chain and then resolves back to a CID. So it's kind of like a mapping function in a way where you're taking that .eth domain and resolving that to a CID. Once it gets it back in Brave, parses the results and determines there's an IPFS record. So it sees the CID, or maybe it sees no record, similar to what happens when it goes to DNS, and it'll throw an error. Brave then performs a lookup on the IPFS record via a gateway or IPFS node. What you saw in the demo was me having it configured to the actual IPFS node. Finally, Brave renders the web page in a separate process, just like any web page. So this is where it becomes very interesting, is like the harder part about this within browsers is the origin itself, which is a fancy way of saying URL. There's slightly different properties within browsers. They define it very specifically. Has very specific properties and security contexts. So for example, this is isolated to the IPFS CID. So local storage for the IPFS CID is set up separately than your access to your facebook.com local storage. So it's treated effectively just as another domain, or in this case, it's referred to as an origin. So this also means that it pops up all the normal browser security models. So you've got things like cores and secure context and all those capabilities. So you can actually still request for the permissions context of utilizing a camera. If you're running some sort of like front-end application that wants to be able to use the camera to be able to record a video or something. So this enables the capability to have a front-end service where you're recording a video, and then maybe what you do is you actually republish that video onto IPFS. Those capabilities and paradigms become possible all within the web browser. And so this DApp works similarly to one being hosted by an HTTPS server, but the backend architecture is slightly different. So this is the final step. Let's work on deploying our own. First, we'll have to install the proper dependencies, and then we'll need to build the website, and then we'll publish the site and view it in the browser. I've tried to pick a few very easy ways for you guys to be able to follow along. Can I get a show of hands real quick? Who actually wants to follow along versus who wants to just watch me do it? Show of hands of people who are going to follow along and do it. We got anybody? Got one. Cool. Got a few? Okay, cool. So if you have a separate website that you want to deploy, such as like your own blog post like I did, let me know and we can go through a bit of a debugging session. If it gets a little bit too off topic, then we'll do it afterwards so that you can actually be able to get that done. Yeah, go ahead.
In this particular case, are they paying a pinning service, or is it just propagated because it's popular?
It depends on the service. So, for example, Uniswap Uncensored, somebody else is paying for that service and propagated, so it loaded very quickly. With my blog post, I was the only one who loaded it, so it took a little bit. And so what I actually did is I pinned it to my own local node, and that sped up the ability to be able to detect it. So it's probably paid. And then you run into how are you hosting it. So there's tools like Fleek that I heard about when I was setting up this demo that makes it possible to be able to put that on. But then there's also the ability to be able to just like have the ephemeral aspect of it as well. So that trade-off of content availability actually makes a very interesting aspect of it, where it's like traditional HTTP resources. I believe, last I'd heard the stats, most web resources are only available for about 28 days in the current version of them, which is where Web Archive becomes very interesting. This actually offers the ability to, when you've deleted that content, to be certain that that content is never really available again unless somebody replicates it and pins it. So, does that answer your question? Okay.
Kyle?
Yeah.
Another question over here.
Yep.
You mentioned Gateway, but is Brave browser also running a node in the app as well?
Yes. So let me just show that real quick. So if you want to access this, you can go to Brave:IPFS internals. And then this is the way that I've accessed it. You can actually do the companion extension, and I've set that up as well. So essentially this button here, my node, links you out to the extension here in the same way. So I'm running a node on local as local host under port 45000. This is my actual node. You can see the files that I have pinned here. It's my site that I was playing around with when I was actually setting up the demo. And so I can actually be able to access like this blog post that I've hosted now. I believe that my site is probably the only one that, or my node would be the only one that's hosting my site, unless Fission node does some sort of replication on the back end in order to replicate those CIDs, because I use their tool and that's what we use in the demo.
So if I'm understanding you right, sorry, my throat's a little, if I'm understanding you right, if you have your Brave browser open, your node is running and your content is available to the world.
Yes, and this is where those privacy trade-offs come into play.
Okay.
So for example, if you're hosting content there, that IPFS, your IP address becomes available from running that node effectively. And so this is where you've got those settings. Actually, let me just go through the demo because I'm covering a lot of these things anyways. I was going to go off on a tangent, but I realized I've already covered it in the slides. So first part is dependency installation. So first we'll want to configure Brave properly by using a node rather than a gateway. This makes this easier to actually deploy this stuff. So the way in which we do this is we go to Brave settings/web3. And then once you're in here, there's a whole slew of IPFS configurations that you can actually set up. So you can change what your gateway is. You can change if you have default backup. You can do automatically redirect. So for example, if a site like IPFS.tech is already hosted on IPFS, it'll automatically redirect it to using IPFS rather than using HTTP. You can also install that extension through this IPFS companion. You can configure sizes, manage your keys, these types of things. So in this case, the default configuration, I believe, is actually ask. And essentially what happens is the first time you visit an IPFS site with a CID, it'll actually ask you, do you want to set up a node? Do you want to redirect to a gateway? Those types of things. This, again, comes down to the privacy considerations feature of if somebody's pulling in this content, then it now becomes possible that when they pull in that content and then it gets cached, their node is then actually re-replicating it back out to the rest of the IPFS network, and that IP address then basically becomes correlated with, hey, you viewed this site. So this is where that trade-off is. So in this case, we'll set it up to Brave local IPFS node, and that's where it just automatically sets everything up for you. Once we've got that, next we'll want to clone a website. I just did Wallet Uncon because I've been helping out with that. It was a public site. I was going to use IPFS Connect and I couldn't find the website. publicly. So you can also do this with any just random website. There's tons of configuration and capabilities to be able to do this with random Jekyll pages and any sort of like static markdown. The docs are fabulous for this, and I've got a link at the end to be able to see exactly in the docs where that information is. So we'll jump out to the terminal and hope this doesn't upset anything. Yep. So we're going to go to div. And we'll go here. And we'll do git clone. I've got to actually make mine SSH based just because that's how I have my git configured. Cool. How are we doing on time?
3 minutes.
Okay. That's all right. You guys built a good tool to make this a little bit easier. I'll have to skip over the dependency of installation of Fission, though, in order to get there. On Mac, you can just run brew install, and you can actually install the tool, and then you can be able to make that work. I appear to be hitting an internet connection, so we're going to potentially audible this to something I've already got deployed. So I talked to you guys about my personal blog. So we'll go to personal here, and I've got this blog available. I've actually already got this configured. So now that I've got this site cloned, effectively what we're going to do as next steps is we're going to install this. Like I said, we'll skip over it. If you want to follow along, you can actually run the Fission suite and get the CLI tool. There's a link to that as well. If you have questions, feel free to grab me after. I don't want to put us behind at the very start of the day. So then we're effectively just going to build the site locally. The Fission CLI is built to work on more complex sites, like I mentioned. For the website that we'll use, we won't need to do any sort of additional build steps. So effectively, the way that we do this is that we go Fission setup. Mine should already be set up in this sort of case, so I don't need to execute any of that. We'll do Fission app register. And in this case, I'm already set up. Effectively, this is just going to redirect you out to your email so that you can link it, and then it'll end up working. And then finally, you can do Fission app publish. And so because I have a YAML file already configured within here, which is what the register step will end up doing, it'll configure for you the capability to be able to actually publish this to an IPNS name that Fission sets up for you under a subdomain. So once this publishes, if I link out here, I'll be able to view the site on HTTPS, and mine's actually automatically redirecting to IPNS. And now you can see my blog post. This is the exact same thing as what you can see on HTTP. Same exact experience, but it's now hosted on IPFS. So that's it. The last piece of this is those links. For anybody who wants a copy of the slides, this is a good place to be able to find the links. There is actually the additional capability to be able to do your redirection to Web3 domains that are supported within Brave browser, like ENS, UD, SNS, and IPNS support. So I've linked out to that as well, which is kind of the follow-on of what you can do after this to be able to get to that uniswap/uncensored.eth TLD style. Time for a quick question, or? Okay, any quick questions?
Excuse me, do you support Namecoin domains in Brave browser?
We do not. We have taken a look at quite a few different name resolution services. Namecoin, I don't believe we've looked at in a while. Handshake we've taken into consideration, as well as I know there's a few others that we've taken into consideration. And it really just comes down to engineering effort in order to support it and the number of like TLDs that are actually being hosted off it and stuff like that. We're definitely open to supporting others. We're not like tied to like any sort of like bias of which one's available. This is a part of the multi-chain experience. So, it's really just about the engineering time and effort to add support for these other naming services.
Thank you.
Something to mention on that as well is we do care about long-term longevity of this. So some of the restrictions that we do set are things like if you're determining a TLD, are you actually going to work with ICANN, or are you causing namespace resolution conflicts and stuff like that? So if the eventual goal is we can integrate this into the web, we need to think about these types of things ahead of time, and that's one of the things that we're doing as like one of the leaders working on this stuff. So see, I'm a minute and 30 ahead, so I'm going to get off the stage.